So we have this question, flood fill of Leetcode 733, and it's a recursion and backtracking question basically. And in previous video, I have shown that how these different direction works. Whenever you are presented some direction, you will be provided with different direction allowed to travel. For example, in this, the question is this is a. I'll just simplify the question. This is a matrix, and there are different number of just a there are different numbers placed and we are provided with some random coordinates. For example, the coordinates will be SR and SC, starting row and starting column. For example, here we are provided with 1 and 1. So this is our coordinate, and from this coordinate we have to travel. We can travel in any of the four directions: up, left, right, and down. And what we need to do, whatever value we are going on. For example, if we are standing here and we are jumping to this, so we need to change this value to the new color, whichever color is provided to us. Right now we have two. So whichever values we can traverse, basically if you are standing here, you can traverse in four values, four direction. But the only constraint is the value on which you are traveling should be same. For example, uh, if this is your matrix and this is 1 and all the other values are 0 0 0, so they are not same, so you cannot travel in any direction and you'll just stay here. And if this is the constraint that next value is 1, this value is 1, this value is 2, and this value is something else 3, so you can only travel in left and right. So these are the constraints and you have to change all the values. So how this work, I if you went up you can change this, if you went right you can change this, then you can come back, you can change all of them. But you cannot go to this one because diagonally traversing is not allowed. You can only go right or left, and you will not go either right or left because these values are not same as your current value on which you are standing, which is SR and SC equals to 1. So how we'll do? What we'll do is basically the concept which I have told in last video, the vector concept. Uh, we'll be using this. We'll be using this because we can definitely derive different directions using this. Even if this question was of eight direction, this is only four directional question. Even if the question was of eight direction, this code will work perfectly. We just need to add more directions here. So this is my direction vector. These are basic things, size, and this is value. Why? Because I need to know on which value I'm currently standing. I'm standing currently on 1 comma 1, so the value on 1 comma 1 is 1. So every value which I'll be traversing should be equals to this value. That's why I've taken this value. Now starting column, starting row, basically my coordinates. This is my image. The name of this 2D matrix is image. Then my NAS, which is direction vector, obviously. Then value and new color. New color I have to put everywhere wherever I encounter the same color as my standing color. Then we'll jump on to the function. Function is extremely simple. There is nothing much. Ignore this line for once. Okay. The simplest concept is if you find that color to be true, if you are moving somewhere, just assume that you are standing. This is one, and if you moved in any direction, left, right, up, down, anywhere, whichever you want, whichever direction you wanted. If you move, and if the value of that direction is also equal to the previous direction or previous, leave the previous. That's why I've taken the value because my value is one. So on stepping on every matrix, if you'll take a bigger matrix, and while stepping on each and every value, I need to check that if that value is equals to my current, my bigger value, which is equals to 1. You should be getting the point. So that's what I'm checking. Actually, I'm not checking that here. What I'm doing is once I'm on that particular column, once I'm on that particular matrix, I'll be changing its value. Basically here I'm changing the value to 2. Okay, just listen to this. Now what is this? These are my four direction travelers, because I have my four direction, that's why I have written four direction traveler. Or you can write nas dot size also. And then what they are doing, I've already explained in my previous video, that R is for row, C is for column, and how they are manipulating the values to go in all the different directions. The only condition which I am checking here is that R should be greater than and C should be greater than 0, which means they should lie in our box, they should lie in our matrix. Then I'll call the function again, solve, without changing my values because I've already changed, and these values are getting changed according to my direction vector, and my direction vector allows you to travel in four different directions. Now the main condition is if you are outside the box. If you are outside the box, basically if you are not present in the matrix, or if you left for some reason, or if you are uh, these values are basically for countering out of bound. One value is if you are smaller than 0. Second value is if you are out of bounds from right side. Then third value is if your column is smaller than 0, which means if you are currently here. Fourth value is if your column exceeds, if you exceed from this side, or if you exceed from this side, basically out of bound. These four values were out of bound. Then another one is if image SR SC, which means if you are standing on a coordinate of or matrix, basically if you are standing somewhere and the value is equals to new color. New colors means the color is already present there, you cannot change. For example, I'll give you an example. uh, if we are standing like this, if we are standing, this is one, this is one, and this is one, this is three, and for example my new color is also three. So if I wanted to go to the right, I'll encounter my three. Okay, so I need not to move in this direction. That's why I've written if image is equals to new. If you'll not write, this will also work. No need to check every time. And if image is not equals to value also, which means this was some condition, this was some condition. Actually, I can delete this condition because these two condition will eventually counter to the same thing. What this thing says is if image of the current row and current column, which means at whichever column or row you are standing, the value of that column eh, should be equals to the value which you are looking for, basically one. The concept is just a second. The concept is whenever you will travel from this one, na, suppose there is a 10,000 by 10,000 matrix. So whenever you will travel, the row or the column or the cell you are reaching on should contain same value as your value column, as your value, basically value as your value. So here we have the value equals to 1, so you have started from 1, so you have to switch each one in the in basically in this matrix. So that's what I'm checking. If the value is not equals to 1, if the value is equals to something else, like here the value was 0, here the value was 0, so I will not visit them and I'll just return from there. So what this thing will do, this thing will help me travel in four direction. This thing will help me to return if some values are different, or if something of out of bound or something, and I need not to return anything because I passed this by reference. So any changes in my image section will be directly reflected to my final answer. So I've already submitted it, and the reason why we have such a low memory space and low space time complexity, because first of all I'm using this vector of vector. What this thing is doing, this is making extra vector, and then 2D vector will be created, then all these things. So passing a 2D vector again and again, and then computing these value. Instead I've seen a solution. Just give me a moment. I've seen a solution. This one was quite efficient, I guess, because what this guy is doing did not do anything special. Simple calling, and after that, same condition. But instead of using that loop, this guy decided to traverse manually, and these are the same thing. These are the same thing. I'll tell you how. I'll tell you how. Alright. Uh, how these are the same one and the same thing. Just give me a moment, because just look at these values. Just look at this value, and I'll draw them for you. Just look at एक second. Yeah. Just look at these value, all these values. Okay. What they are showing. This is I minus 1 j. Okay. This is I plus 1 j. This is I j minus 1, and this is I basically j plus 1. Now let's have a look at our direction vector. What all values we are holding. Okay, so these are the values which we are holding, and I've already told you that these value gets added to our current coordinates. Basically, these value will be added. Okay, let's add them. If I'll add them, give me a moment. If I'll add them to our simple I and j's, if I'll add them to our simple I and j, okay, let's start adding. Adding 0, I plus 0, then adding 1, okay, second value. if I'll just add I plus 1 and nothing to 0, basically nothing to j. Okay, then if I'll add 0 and I'll subtract minus 1, and if I'll subtract minus 1 and add 0, so they'll give me I j plus 1. Okay, I plus 1 j, I j minus 1, and I minus 1 j, which are nothing else but this value points to this, okay, and this value points to this value again points to this, and this value luckily points to this. This is minus 1, not plus 1. This is I minus 1, which I have already written. So it is one of the same thing, but this guy just decided to do it manually, and I created a bigger function which will be helpful in further questions where the directions can vary, and also in graph. So that's it.